Hey guys, Miss Middleton here. Today, after your notes, after you do your Ed puzzle notes, there is this Igneous Rock Lab that should be in a folder that your teacher has put it in. For my classes, it's in the Unit 3 Lithosphere folder, and then in the Rocks and Rock Cycle folder. It'll be in there, and it'll be labeled, at least for my classes, Igneous Rocks Lab Samples List, okay? The first thing you're going to do here is there are 8 rocks that have been given to you, 8 igneous rocks, and you are trying to identify them. So not only do you have an image here, you have a little description underneath here. And what you're going to be doing is you're going to take that description and look at this identification scheme that is right here. You can see that we have some of the rocks crossed out that you don't have to worry about. They're not an option. And so I'm going to do maybe the first one with you just to show you how it works. This is one of my favorite charts just because it gives you so much information about each rock. So this first one is a clear glassy rock that appears black. So the first place you should always start is over here at the textures. So our textures are either extrusive or intrusive or both. Remember, intrusive means that it formed inside the volcano. You're usually going to have a coarse texture, whereas extrusive, it has exited out of the volcano and it has cooled very quickly. So our first rock says that it's glassy. So this is the best option right here. You're going to stay in this column. It is non-crystalline, which just means that you can't see any crystals. That's how quickly it cools. And the only really option for this is obsidian. It even says it usually appears black. And it appears black. So that would be the answer you put in there. You're going to go through and you're going to write in or use that chart for even more of these. If it's ever talking about, hey, it's light colored, if you're not sure where that is, down here it has a color area. So if it's light in color, it's going to be on this side. If it's dark in color, it's going to be on this side of the chart. If it talks about the density being high, high density rocks are going to be over here. Light density or not very dense rocks are going to be on this side. And then composition, if it's felsic or mafic will be over on this side, felsic rocks over here. There is some composition stuff down here that you don't really need to know too much with. It's kind of cool. Again, I love this chart because you could look at granite, look at the box that it is in, and all of these minerals right below it could be in granite. All right. For diorite, just these minerals in this column, whatever it crosses into would be in it. So you don't need this part really for the rest of the paper after you identify your rocks here. But it's just kind of cool to look at if you're a nerd like me. All right. You then have these conclusion questions. I am going to read through them just because it's good to take in both visually and auditorily the information. So conclusion question, an important key to classifying igneous rocks is where the rock originally formed from, if it originally solidified from magma or lava. What are the names of the 2 major classification groups for igneous rocks that are based on where the rock formed? Again, if you're not sure, it is up in here. You can look at the environment of formation. There are 2 options that I have already talked about. Is granite intrusive or extrusive? This also might be a key to number 1. Is basalt intrusive or extrusive? Is obsidian intrusive or extrusive? And then what is obsidian's texture? So remember, texture is going to be in this column. So if it ever asks you, hey, what is this thing's texture? Like granite's texture is coarse, or andesite porphyry, it's porphyritic, meaning that it has both big and small crystals. All right. The time it takes for the rock to solidify from magma or lava crystallizing determines the size of the crystal minerals in the rock. Rocks that cool underground cool more slowly and have larger crystals. Rocks that cool above ground cool more quickly and have smaller crystals or no visible crystals. Look at the grain size and the texture columns. Which igneous rocks tend to be coarser in texture with larger mineral crystals? So again, you're going to use this. And tell us if it's intrusive or extrusive. Does intrusive igneous rock form below or above Earth's surface? Does extrusive igneous rock form below or above Earth's surface? And then you're going to go through, find each one of these rocks, and you're going to tell me the grain size and did it cool slow, fast, or very fast. So grain size, again, right here's grain size. And if it's non-crystalline, just as a heads up, that usually means it cools so fast. It was like flash cooled. No crystals could even form. If it's cooled pretty fast, it'll have so less than 1 millimeter. It usually is going to cool pretty quickly, whereas if it's larger, it's going to cool slowly, just like that said before. Igneous rocks form the basis of much of Earth's crust. Earth's crust type has unique mineral composition and magma type based on where they formed. Continental crust tends to be manufactured by processes associated with felsic magma. So continental crust equals felsic magma. Oceanic crust tends to be manufactured by processes associated with mafic magma. So oceanic crust, you should think mafic. Locations where continental and oceanic crust meets and mix tends to produce intermediate magma. So like in between, if that helps you. Intermediate, in between, kind of the same start. Number 7, looking at the mineral blue portion of the identification scheme above, complete the chart below. So again, you have felsic versus mafic. You're saying, all right, where's that chart? There it is. This part here. Here's felsic, here's mafic. Tell me about the density, tell me about the color. And then tell me 2 minerals that would be considered either felsic or mafic. And then number 8, looking at the image below, compare and contrast continental and oceanic crust. Finally, infer which magma type makes each. So you're literally just going to look at the picture for if it's thicker or thinner. The density, you can use number 7 here. If you remember, it talks about continental versus oceanic crust right there, as well as mafic type, mafic or felsic, what type of magma it is. You also, when it comes to the density, you could look and see how this continental crust has a larger volume. And if you remember how density works, the larger the volume, you need to think about how that affects the density. If you make the volume smaller, does that increase density or decrease density? That's another way you can think about it if you don't feel like scrolling up to the chart. This last part, true or false, the volcano right there, shown to the right, would produce an intermediate magma type. So you have oceanic crust subducting down. That oceanic crust is going to melt a little bit and rise, and then continental crust here. So would that make intermediate magma? You can click on this little link here. It'll take you back up to where it talks about, hey, how do we get intermediate magma? And then you can make a better educated choice right there. Once you are done filling this all out, you're going to submit and have an awesome weekend.